Now we're ready to calculate the values for the chi-square. And again, according to the formula, we just need to do this. We now have all of our expected values based on the total, and let's see what we can do. Alright, we need to do this for all of the specific data. So let's see, the first one would be 10 minus 9.9 squared all over the expected value 9.9 plus. Let's finish the one for program 1. So here we have 20 minus 20.1 squared all over 20.1. This thing is 20 plus. So we can do this one now. We have 15 minus 9.9 squared all over 9.9 plus 15 minus 20.1 squared all over expected 20.1 plus, almost there, we have 5 minus 9.9 squared all over expected 9.9, and finally we have plus 25 minus 20.1 squared all over 20.1. See, we need to add this all up. Let's see what we get from it. You see that it's very hustling to compute for all of this. I'm going to grab Excel to try and partially help us out. So 10 minus 9.9 squared divided by 9.9. I'm just going to leave it there. And next value is 20 with parentheses 20 minus 20.1 squared divided by 20.1. Leave it there. Next value we have parentheses 15 minus 9.9 squared divided by 9.9. I forgot to put an equal sign. Of course it wouldn't work without an equal sign. And the fourth value is 15 is equal to 15 minus. So I know you can't see that, but I'm just copying 15 minus 20.1, which I'll let you see right there. Alright, divided by 20.1, and let's see, we have 5 minus 9.9 squared divided by 9.9. Just gonna show you in a bit there. There we go. Press enter. And finally we have last 25 minus 20.1 squared divided by 20.1. Alright. So as we said, we need to add this all up. Which one is the particular chi-statistic, but we need to sum it all up to get the chi-statistic itself. So our chi-statistic is 7.5. 7.5. Let's write it. It's 7.5. Alright, now how are we going to use this value? We need to find out. What is our assumption? So first we need to grab an assumption that we assume that the program has no effect. The program's no effect, and the alternative is it has an effect. Notice that I did not choose what kind of effect it was. The effect as I told you, can be an increase or a decrease, but in this case I'm just going to discuss about effects in general. So it has an effect, either that it increase a post test or it decrease a post test. We don't know. It's just that is there any change? All right. Now, how was I able to say this H naught? As you can see, the expected values that we're using right here is based on this total, and this total is adding up all the persons who got a higher post test to the persons who got a lower post test. So if I got the percentage from this distribution, I'm actually this distribution. I'm actually assuming that this is the normal way. As I said, this is the normal way that people would be behaving without any programs at all. So this is where I base my expected, and hence this expected values is saying this is what this would be my distribution if there's no effect. So hence, if our value for the chi-square has a low p-value, then it means that has a low p-value. Remember, so it means that this statistic does not belong to this no effect distribution, and hence we would say that it doesn't belong to this no effect distribution, and hence if it doesn't belong to the no effect, it belongs to the effect distribution, which means that we would accept the H1 hypothesis. So how are we going to check how low the p-value is with respect to this chi-statistic? Well, again, we would consult our cumulative distribution. But before we can do that, we need to figure out the degrees of freedom. And in this case, the degrees of freedom is somehow different. For contingency tables, it is row minus 1 times column minus 1. What it's saying is how many rows do we have? So in this particular case, we have 2 rows. So that would be 2 minus 1 for that part. And how many columns do we have? We have program 1, program 2, program 3, no program. So that's 3 minus 1, resulting to a degrees of freedom of 1 times 2, 2. So we will do a 2 degrees of freedom cumulative frequency distribution based on a chi-square. So that's what we're going to do next, and figure out the p-value for the particular 7.5 chi statistic.